So this video we're going to be graphing quadratic functions and then we're going to be transforming them. So vertex form is going to look like this. So normally we're used to seeing the y equals ax squared plus bx plus c. That is standard form, which we're going to be talking about next time. This is going to be vertex form, so this is what we're going to be graphing off of this time. This actually looks very similar to the equation y equals a x minus h plus k, where our h value is going to flip. So whenever we pull our h value out of this, it's also going to flip. It's very similar to what the absolute value is. Instead of a v, it's going to be a u shape this time. Okay, AOS is going to be my axis of symmetry. So if you would like to write in axis of symmetry, so it's going to be dividing my graph in half, so it's what we're going to be mirroring off of, okay? So we got x equals h, so it's always going to be our h value here, and remember it's always going to be the opposite of what we think it's going to be. So if I were to graph, if I had this graph and it's like this, my AOS is going to be the thing that divides it in half, and we're going to mirror our right side off of our left side, or our left side off of our right side. So it's going to be the thing that divides it into two halves. Okay, our vertex is going to be our point. It's always going to be the highest point or lowest point in our graph, and it's going to be represented by the hk in the equation. So the h and the k, remember the h is always the opposite. So it's going to look something like, if I were to graph this is going to be my vertex. Normally the point is x comma y, but in this situation it's going to be h comma k, and our h is always our opposite value. Our vertex is either going to be the highest point or the lowest point, and it's what's going to be the top or the bottom of our U shape. Okay, so here's our first graph. So my AOS was always the x equals h, and my vertex was the h comma k. So in this, we need to make it look like our vertex form. So if I do y equals my, it lets me write a x, the thing that I can add to my b next to my x that's not going to change it is going to be a 0. And we can add our 0 on the back end. So right now, my h is 0, my k is 0, so that means my vertex point is going to be 0, 0. And this is going to be, oh my gosh, x equals 0. So if I were to graph that point, it's going to be starting at 0, 0. And my AOS is going to be that dashed line that we're going to mirror off of. So it's going to look something like that. Okay, but I don't have a U shape, so I need to get more points in here. So we're going to do a T-chart. And I always pick 2 points to the right that are closest to that vertex or AOS. So 1 and 2 are going to be 2 easy points to plug in, and I'm going to plug them into my original equation. So I'm going to get y equals 1/2 times 1 squared. You always do the exponent first. So 1 squared is 1. 1/2 times 1 is 1/2. So we got 1 1/2, and then we're going to plug our 2 in. 2 squared is 4. 1/2 times 4 is 2. So when I graph it, we got 1 1/2, so I go right 1 up 1/2, and my other one was 2 2, so I go right 2 up 2, and then I mirror off of my dash line. Okay, so it is 1 away on this side, and it is 2 away on the left side for that one. So my U shape is going to look like that. Okay, maximum versus minimum, so if this is my minimum and this is my maximum, I'm going to draw a generic of what a minimum is going to look like. So it's always going to be the point that your vertex is at. Okay, so a minimum value is when your vertex is at its lowest point, and our equation for that is going to be something like this, where it is always positive here. The reason I know is because this kind of looks like a happy face. So whenever it's positive, it's going to make a happy face, and it's going to be a minimum. For this one, It kind of looks like a sad face. So it's going to be when this point right here, my A value is negative. It will be a sad face or a maximum value. So that's kind of how you can tell just based on the equations if it should be a happy face, sad face, maximum, or minimum. So minimum is when the vertex is the lowest point. Maximum is when it's at its highest point. Translation. So my generic x squared graph here come on. My vertex is going to be at 0, 0, so if I graph that 0, 0, right there, I want 2 points to the right of it, so let's do 1 and 2. So if I plug 1 in, 1 squared is 1, 2 squared is 4, so if I graph 1, 1, I go right 1, up 1, and then 2, 4, I go right 2, up 4, and then I'm going to mirror it. So this is what a generic parabola should always look like, just the normal y equals x squared. And now we're going to shift it. So if it's a minus 5 on the outside, it means it's going either up or down. Minus 5 means it's going down 5. So I'm shifting all of my points down 5. So shift it down 5, down 5, down 5, down 5. So I shift my whole graph down 5. So it's going to be just like when we were doing absolute value shifting. Okay, if it sits on the inside, it moves left or right. This minus 4 means normally you would think left, but it's always the opposite. So it's going to go right 4. So I shift all of my points right 4. So all of my original graph points got shifted to the right 4. So you can see my left graph over here, that's my original, it shifted right 4. Okay, this one was down 5 because it's on the outside, so you can see that my original shifted down 5. Okay, describe the transformations. So if it is on the outside, it is either going up or down, so this is going to be going down 1. Up or down, this is going to be going up 6. If it's on the inside, it goes left or right. It's always the opposite of what you think, so this one is going right 2. This one is the opposite of what you think again, because it's on the inside, so it is going left 2. If we're multiplying and it is smaller than 1, it is going to compress it. Compress by 1/2, so it's going to get skinnier, or my points are going to get closer together. And if it's bigger than 2, it's going to stretch it. So all of my points are either going to get farther away or my graph's going to look like it's getting fatter. Okay, this one, got a plus 6 on the outside. It's going up 6. Minus 2 on the inside, it's opposite of what you think, so it is going right 2. Plus 3, we are going up 3 and left 1. Left 1. Okay, domain is all of my x values, range is all of my y values, so I want to talk about my graph going across those certain values. So if a parabola never ends going left and right, okay, that means I should include all of my x values. It's going to hit all of my x values, so my answer for this is going to be all real numbers. So either that sign, or you could write out all real numbers if it lets me write all real numbers. Okay, my range is all of my y values. So right now, my y value is right here, so it's sitting at 0. And I want everything bigger than 0 because it's hitting this y value at 1, 2, 3, 4, 5, all the way up to 80, all the way up to 1 billion. We're going to be hitting it at some point. So I want everything that is bigger than 0. It hits at 0, so it includes 0, but I also want everything that is bigger than 0. Okay, this one, if my graph never ends going left and right, it's going to include all of my x values again, so we're going to put all real numbers. My y values here, it looks like it's hitting at 3, and I want everything bigger than 3 again, because it hits at 4, it hits at 5, it hits at 6, it hits at 1 billion. So I want to include 3, but I also want everything bigger than 3. Okay, if my graph never ends going left and right, we're going to do all real numbers again for my x values here. My range value this time is hitting at -2. And I want everything bigger than -2 again, because it hits at 0, it hits at 1, it hits at 3, it hits at -1. Okay, so I want everything bigger than -2. Okay, my domain's going to be all real numbers again. My range this time, this point right here, hits at -2, 0. So the y value it's hitting at is 0, and I again want everything bigger than 0. Okay, domain is going to be all real numbers again. My range, it looks like it's hitting at, we'll say -5, but this time I want everything that's less than it. Okay, I want -20, I want -40, I want -60, I want -80. So I want all of my points are hitting at things less than -5 this time. So this time we're flipping our inequality. -5 is the greatest because it hits at -5, so we're including it, but I also want everything less than it. Okay, domain is going to be all real numbers. It's hitting at 2 for my y, and I want everything less than 2 again, so 2 should be the biggest point that it should be at, and I am including it. Okay, we're going to graph. So my vertex is always my HK, so this is A, this is H, this is K. Remember, it's always the opposite of what we think, so it is going to be a +4. And my K value is a -2. This is x equals my H value, so 4 again. So when I'm graphing 4, -2, I go right 4, down 2, and I do my AOS off of that. And now I need more points to find my V. Okay, if we look, this is a +3, so it should be a happy face. So it should be a minimum. We should be seeing a minimum here. And my vertex is always my highest point or my lowest point. So my vertex is going to end up being that minimum point, but we'll see it when I graph it. First off, I need some extra points. So let's pick 2 points to the left of my AOS. So we could do 2 and 3 and plug those in so we can find our y values. So I got y equals, I don't want to do it there. Let's do it here. Y equals 3. Come on. There, we'll do it at the bottom. Come on. Y equals 3 times 2 minus 4 squared minus 2. We work the inside of the parentheses first, so 2 minus 4 is -2. In the order of operations, we always square first. So y equals 3, or -2 squared, which is 4. Then we multiply, so 3 times 4 is 12. 12 minus 2 is 10. So we got 210, and I'm going to erase that so we can find our 3. So y equals 3 times 3 minus 4 squared minus 2. So we got 3 minus 4 is -1. We always square first, so -1 squared is 1. 3 times 1 is 3. 3 minus 2 is 1. So if I graph 210, I go right to, remember you go from the origin to graph points, right to up 10. So right there. And then my other one is 3, 1, so I go right 3, up 1. I mirror, so I'm 1 away from my dash line, I go 1 away on the other side. I am 2 away up here, so I go 2 away on the other side. And I connect my points. So you can see that it's a minimum value at my vertex, so it's going to be at 4, -2. My domain's going to be all real numbers. My range, let's see, it hits at -2 for my y value, and I want everything bigger than that. So my inequality should be eating my y. Okay, our next one, we got A, H. Okay, so my H, is -3 this time, and my K is -4. So x is equal to my H value, so -3. So if I graph that, I go left 3 down 4, left 3 down 1, 2, 3, 4, and I do my AOS on that. Now I need more points, so I'm going to pick 2 points to the right of it this time. Come on. So we could pick -2 and -1 to plug in. So I'm going to do it at the bottom. So y equals, we're putting in -2, so -2 plus 3 squared minus 4. -2 plus 3 is 1. 1 squared is 1. 1 minus 4 is -3. So this is -3. Now let's plug in -1. So y equals -1 plus 3 squared minus 4. -1 plus 3 is 2. 2 squared is 4. 4 minus 4 is 0. So if I were to graph these, I go left 2, down 3 for -2, 3. So left 2, down 1, 2, 3. I'm going to mirror it across that dash line. And then my other one is -1, 0. So I go left 1 and plot my point. That is 2 away, so I'll go 2 away on the other side. Okay, it looks like my vertex is at my minimum. It's the lowest point. So we say minimum, and then we say that vertex. So -3, -4. My domain is all real numbers. My range, it looks like my y hits at -4. And I want everything bigger than it again. Okay, so we got A, H, okay. So my H is going to be -3. My K is -8. So X is equal to -3. So I go left 3, down 8. Left 3, 1, 2, 3, 4, 5, 6, 7, 8. My AOS off of that. Okay, it's a negative, so it's going to be a sad face because my A is negative. So we're going to have a maximum value in this one at my vertex, so -3, -8. My domain's always going to be all real numbers, and if my max is going to be that -3, -8, that means my y value is going to be hitting at -8. Okay, and then I'm going to want everything less than that, so it's going to be this. Okay, let's go ahead and get more points. So if I pick 2 things to the right of my dash line, we could do -2 and -1. Oh, this is a -7. Shoot. That's why. It should be -7. I read the wrong one. So we go left 7. 1, 2, 3, 4, 5, 6, 7. Down 8. 1, 2, 3, 4, 5, 6, 7, 8. That's where my vertex is going to be. There we go. All right, so that means this is -7. Okay, so now I'm going to plug in points that are closer to that, since now it's correct. So we're going to do -6 and -5. So I'm going to pause and I'm just going to plug it in. You could type it into your calculator to get them. I would do it yourself and then check with me. Okay, so this is what I got. So I'm going to go left 6, down 11. So it's going to be like right here. I'm going to mirror it across. And then the other one is -5, -20. This is why we pick close ones, because that's going to be like way off. So there is my graph. So you can see how it's a maximum at my vertex, -7, -8. We got all real numbers. My y value is -8, and then I want everything less than -8, because all of my y values hit at less than -8. Okay, if we go up, you can notice that this should be shifting left 7, so my vertex shifted left 7, it went down 8, okay? This is a reflection over my x-axis. If we look at this one, this should be going left 3 and down 4, so that's why my vertex is left 3, down 4. And this one, it should be going right 4, down 2, so that's why my vertex got shifted right 4, down 2, and that 3 means that it's getting fatter, which is why all of my points got farther and farther away from each other.